Okay, obviously we have to also now think about extratropical influence on the tropics and then look at the tropical extratropical interactions. This is a nice figure which is also in Peter Webster's book, and the course I recorded based on it. It's from a paper by his team. Looking at the upper level winds, this is on 370 Kelvin isentrope. I didn't put the caption here, sorry, but the main thing you want to see here is in the upper level, January and July, there is various magnitude of westerly winds in the eastern Pacific and in the Atlantic region coming down here. So these westerly ducts provide the opportunity for this jet coming off of here or off of here, which go unstable, produce breaking Rossby waves and so on, and pump potential vorticity into the deep tropics. And remember, we said deep tropical diabatic heating can produce Hadley cell and momentum and heat fluxes northward. Here we are talking about these recursive breaking at not climatological timescales, but we are specifically looking for subseasonal timescales, and it turns out that indeed that's what happens. That also comes through, for example, the phase of the MAO and its relation to MJO phases and so on. And the main story is also that in July climatology you have the PV trough that is coming down. It's called the tropical upper tropospheric trough, TUTT, by Webster in his papers and books. So those are the favorite places where extratropics can put energy into the tropics, and there is plenty of evidence that some of the MJOs are triggered by these incursions from the extratropics. So the MJOs, we said some are primary and some are secondary. So the secondary ones were the ones that propagated all across and came back and got re-energized or reborn, and the primary ones are the ones that are generated newly, and many of them are generated by these extratropical influences. And some modeling experiment by Alex Hall claims that maybe half of the tropical interseasonal variance could be explained by this incursion of extratropical signatures into the tropics. The same paper also shows this nice diagram for July climatology, but for a particular day, and you can clearly see the incursion of this PV flux from the mid-latitudes into the deep tropics, and then it has these streaks that go all the way across westward into the African region, and you have in July the so-called Asian potential vorticity trough. So you have circulation around it. So the monsoon, Tibetan plateau heating and so on produces this trough here, and things are happening around it. So you can see this is the climatological picture of July PV, and you can clearly see the Asian low here. And if you look at the fluxes at 30 north and 10 north PV fluxes, you can see the longitudes where tropics are sending PV flux north and extratropics are sending it south. So negative here is coming south, positive going north, and there is similar structures at the 10 north latitude, and much more in the band here in the eastern Pacific, whereas at 10 north that's not so strong. So it re-emphasizes the points we are trying to make, but more specifically now you can see this Meteosat infrared image of tropical plume or northwest Africa. So Africa is over here. You can see that for March 31, 2002. Superimposed are streamlines and isotax on the 345 Kelvin isentrope. You have to carefully pick which isentrope you want to look at, because some of them run into the mountains like the Himalayas if you pick 330 for example. Okay, so dashed contours, blah blah blah, from European Center Medium. So they are also using reanalysis data to put in some information on top of the satellite information. But you can clearly see this intrusion from the extratropics into the tropics. So you're looking at the sphere here and the Atlantic longitudes and Eastern Pacific over here. So that's kind of confirms what we have been saying. Another way to look at it is to look at the climatological boreal U prime V prime mean at 200 hectopascal, where U is the zonal, V is the meridional, of course. They are high pass filtered, so you're looking at eddy fluxes at periods less than 10 days. And positive correlations obviously mean that U prime and V prime are typically in the same direction. And you can see the intrusion of the eddy fluxes from mid-latitudes down here into the tropics, especially in the Eastern Pacific band. Okay, so that is obviously different in the southern hemisphere because of its circular ocean configuration, which we will not touch on here. The dynamics changes a little bit, but you can see specific examples here. Daily boreal winter, December 1 to March 16, intraseasonal covariance between 200 hectopascal high pass momentum flux U prime V prime and low pass layer integrated diabatic heating Q. So there is again an indication that the low pass diabatic heating is associated with the eddy fluxes. You can also look at that as Elias and Palm fluxes, which is a flux vector that combines the momentum and heat fluxes, and there are relations between the way it points and which flux dominates, which we will not get into here. So this is DJFM climatology and for 1989. So UV and Q and UV and Q. U indicates zonal, V meridional. High pass filter retains periods of less than 10 days, and low pass filter retains periods of greater than 20 days. And again, the point is that extratropical eddy momentum fluxes can initiate MJOs in the deep tropics. Okay, so there is, make sure you understand this, there is a low frequency sustained heatings in the tropics, which are related to the Hadley cell and the poleward fluxes that we talked about. And then there are these intraseasonal and synoptic timescale intrusions from the mid-latitudes, which can trigger subseasonal MJO initiation in the deep tropics. Okay, so this is another figure of the same thing. High pass meridional V prime for February 19 and low pass layer integrated diabatic heating. I won't go too much into this, but I think this is showing that the B here is heating given in units. So again, confirming the same. So if you just look at V2 prime, you don't see much structure here other than the mid-latitude jet variability. But if you look at the UV flux, then you see much stronger equatorward intrusion that correlates with the diabatic heating at subseasonal timescales in the tropics. Okay, so we are emphasizing the point that extratropics clearly have a way to influence subseasonal variability in the deep tropics, at especially MJO initiation. And now we have done the tropical influence on extratropical circulation anomalies at subseasonal timescales and extratropical influences on the tropical diabatic heating at subseasonal timescales. We will now try to put the picture together and do the extratropical tropical interactions and teleconnections. Okay, interesting story. The math is heavy, as I said, but we are just explaining the physics and not getting so much into the into the math of the calculation, especially the eddy fluxes and Eliason-Palm fluxes and so on. But again, to remind you, Holton has very nice details that you can look up, not necessarily at subseasonal timescales, but they will help.